of a cadmium electrode and a 1 molar cadmium nitrate solution and a chromium electrode in a 1 molar chromium nitrate solution at 25 degrees C, which gets oxidized and which gets reduced spontaneously. Okay, so a couple of things here before we start off this problem. Spontaneously means it's going to happen on its own, and that means a positive voltage. Okay, so we want our voltage to be positive. Okay? And then what is EMF? EMF stands for electromotive force. Okay, this is just a fancy word for voltage, electromotive force. All right, a cadmium electrode. Okay, so a cadmium electrode, we're going to call that cadmium solid. Cadmium nitrate, we're going to have cadmium ion and nitrate ion. Okay, cadmium ion and nitrate ion. Okay, we have a chromium electrode. A chromium electrode is chromium solid. And then chromium nitrate is going to be chromium ion and nitrate ion. Nitrates are all dissolved in water. Okay, so spontaneously means positive voltage, and cadmium ion. So we're going to look at our standard reduction table. Okay, where is our standard potential table? Okay, I see you have it there, Susanna. Very good. Okay, so make sure you bring this to the test. Okay, make sure you bring this to the exam. Okay, one of these is going to be the anode. The other one is going to be the cathode. All right, so first of all, let's go find cadmium on this sheet. Okay, where is cadmium? All right, so cadmium is here. We'll write it down. Okay, this is the cathode. Okay, remember, cathode and anode must come together. Okay, this is reduction. Reduction happens at the cathode. Red cat. So I'm going to write this down along with the negative. Okay, so this, I'm going to write this down along with the voltage. Cadmium plus 2E minus goes to cadmium solid minus 0.40 volts. That's for this. We'll do it in blue. Minus 0.40 volts. All right, in black we'll do the chromium. Okay, do you guys see the chromium? I see the chromium. Okay, here's the chromium. Okay, minus 0.74 volts. Okay, so one of these has to get flipped. I'm going to write this down as is. Now, spontaneously, okay, that means positive voltage. So I'm going to flip one. Which one am I going to flip to get a positive voltage? Both of these are reduction and both of these are cathode. But remember, what makes a battery? Cathode and the other one? Anode. So which one am I going to flip to make it an anode? Top one or bottom one? Yeah, we're going to flip the bottom one. Okay, we're going to flip the bottom one. This is the only way we can get a positive voltage, and a positive voltage means spontaneously. So we will flip the bottom reaction, half reaction. Okay, so when we flip the bottom half reaction, we're going to get Cr plus 3 plus 3E minus goes to Cr solid. Okay, what will this be in terms of voltage? Okay, this is going to be positive 0.74 volts. Will this be the anode or the cathode? Okay, yes. We're going to leave this one the same because, we're going to have to flip one. One is the anode, one is the cathode. So I'm going to do this the same. And this is the cathode. All of these are the cathode on the sheet for the exam. And that's minus 0.40 volts. Okay, so we're going to cancel out the electrons now. Okay, in order to cancel out the electrons, okay, what do we need to do? Okay, I'm going to multiply the top reaction by 2. And what will I multiply the bottom reaction by? Okay, 3. So this is a 6 electron transfer reaction. 6 electrons. Okay, make sure you write this down. This is a 6 electron transfer reaction. Okay, 6 electrons are being transferred between chromium and cadmium. Chromium is being oxidized. Cadmium, gaining those electrons, is being reduced. All right, so multiplying this out, I'm getting 2Cr plus 3 plus 6E minus goes to Cr solid, 2Cr solid. All right, question for you. What is the voltage? Did you say the same, Susanna? Very good. This is the same. Okay, what did we mention here? That's very important. All these numbers. The only thing that changes is what? The sign. Okay, these numbers never change. So multiplying it by 2 will still make this positive 0.74 volts. Okay, in blue we have the cadmium. We're going to multiply this by 3 to cancel out the electrons. I multiplied this by 3. What is my voltage? Same. Okay, minus 0.40 volts. Good job. Okay, you have to flip one, okay? Okay, flip the bottom half reaction. Okay, so flipping the bottom half reaction, this 6 electrons cancels out with this 6 electrons. Okay. And then we get our net as 2Cr plus 3 plus 3Cd solid. And this goes to 3Cd plus 2 plus 2Cr solid. Alright, so positive 0.74 volts minus 0.40 volts. Okay, this will be E cell. We have to flip one of these. Okay, so we flip the chromium, so we have to flip this. And then this becomes E cell, and then E cell is what's 0.74 minus 0.40? It's going to be positive 0.34 volts. So the workout is here. We did it again, but you're going to flip one. Okay, one remains the cathode, the other one remains the anode. Okay, why did I flip the bottom one? Okay, because as Susanna said, we flip the bottom one, making it the anode, so that we can get a positive voltage. Okay, which one do I flip to make it the anode? The bottom one, to make it spontaneously, and spontaneously means positive voltage. Oh, yes. Here we go. Here we go. You go All right, so we'll do another practice one like this. You can check my work. You can check the solution out. Let's go ahead and move on. There's some equations that I'm going to give you on the test. So let's go now to page 7. Right, I'll give you this on the exam. Okay, I'll give you this on the exam. This relates a voltage. Okay. Okay, which is this chapter. Okay, this relates equilibrium, whether we'll have more products at the end of the reaction or more reactants at the end of the reaction. So this relates equilibrium. Okay, this was chapter 16 or so. This is chapter 18. And then chapter 17, thermodynamics. Okay, so this is thermodynamics. Okay, energetics. Batteries. Okay, I think it's in my office, but I don't want to interrupt class to go to get it from my office. I think these students deserve my time. All right, so these relate all three of these. Okay, so E cell is equal to RT divided by NF natural log of K. Okay, F is called the Faraday constant. Okay, and the Faraday constant is 96,500 coulombs per mole. Okay, this is a constant that I will give you. Okay, the C here is coulombs. It's a unit of charge. Okay, so that's one equation. I'll give you this on the exam. Okay, so you do not have to memorize it. Okay, this is how we get E cell, the voltage, okay, which is anode and the cathode. Okay, N here is the number of moles of electrons. This is a 6-electron transfer reaction. This is a 2-electron transfer reaction. This is a 3-electron transfer reaction. Okay, and R is the gas constant, okay? R is going to be 8.314 joules per mole Kelvin. That's one equation. Here is another equation. Delta G is equal to minus RT natural log of K. All right, so remember this is the Gibbs free energy. If it's negative, we call that an exergonic reaction. Okay. Okay, if it's positive, we have an endergonic reaction. Okay, and then this is delta G, another equation. This is minus NF E cell. So thermodynamics, battery voltage, delta G, K. Okay, equilibrium constant. All right, I'll give you these equations on the exam, but can we go from thermo to equilibrium to a battery? Okay, so let's review here. If you have a positive voltage, if you have a K that's really large, and you have a delta G standard state or non-standard state that's negative, okay. What do all of these three represent? Okay, all these three represent reactions that favor the products. Okay, positive voltage means that obviously a battery. Okay, a negative voltage is a dead battery. K is greater than 1. We're favoring the products, very large equilibrium constant. And an exergonic reaction is one that favors the products. It gives off free energy. Okay, so all of this favors the products. Okay, what situation favors the reactants? A reaction that does not favorable to go. Okay, it's going to be the opposite. Okay, it's going to be a negative voltage. Okay, it's going to be a K less than 1, and then a delta G that's positive. Okay, this scenario, this situation favors the reactants. So this is the situation. All right, so can we remember this for the exam? Okay. Okay, what is a reaction, electrochemical reaction that favors the products? Positive voltage, equilibrium constant greater than 1, a delta G that's minus it. Okay. What is something that favors the reactants? A negative voltage, an equilibrium constant less than 1, and a delta G that's positive. So that's shown here in this table. And I'll give you these equations, okay? Relating chapter 16, 17, and 18. Chapter 16 was equilibrium, chapter 17 was thermo, and then chapter 18 is batteries, voltages. All right, so calculate the equilibrium constant for the following reaction at 25 degrees C. Okay, it's asking for the equilibrium constant. All right, so we'll break this down. We have Fe plus 2 goes to Fe. Why don't you just... All right, we want to break this down to oxidation and reduction. So how many electrons and where do we need to put them for this to be balanced? We got 1 Fe, 1 Fe. And how many electrons do we need to balance it? Okay, 2 on the reactant side. Okay, very good. Is this oxidation or reduction? Oxidation or reduction? What about all of these reactions? These are all reductions. Where are the electrons going? Are we gaining electrons or losing electrons? Okay, so we're gaining electrons. So we're gaining 2 electrons, and that is reduction. Okay, reduction. Where does reduction happen in a cell? Cathode or anode? Cathode. Okay, so what's the voltage associated with this? All right, so minus 0.44 volts. Okay, minus 0.44 volts. Okay, this is reduction. You're gaining 2 electrons. Remember Leo Ger. You're gaining 2 electrons. So this is reduction, and this is the cathode. And this is minus 0.44 volts. Okay. All right, let's do in blue. We've got Ag solid goes to Ag plus. I'll ignore the 2's, but if you want to keep the 2's, you can, but actually the 2's cancel. Okay, so we have Ag solid goes to Ag plus. All right, how many electrons and where should it go? to balance this. We have 1 Ag, 1 Ag. How many electrons and where? How many electrons? 1. Okay, and where should they go? Product side or reactant side? Very good. All right, thank you. Okay, the product side. This balances out. Is this the cathode or the anode? Right, if this is the cathode, then this one has to be the anode. Very good. All right, let's look this up on our sheet. What voltage are we getting? Where do you see this here? It's right. Is it 0.80? What do we need to do? We flipped it. So when we flip it, what will it become? Not positive 0.80, but negative 0.80. Okay, so this becomes negative 0.80. Okay, we're going to multiply the bottom reaction by 2 to cancel out the electrons. Everyone see this? Okay, so this is a 2 electron transfer reaction. Okay, remember I multiply by 2, but this still stays the same. Okay, so this is a 2 electron transfer reaction. Okay, so we have the E cathode and the E anode. We add them up, we get this becomes 2 Ag solid, goes to Fe plus 2 Ag solid, goes to Fe solid plus 2 Ag plus. Alright, and then E cell would be minus 0.44 minus 0.80. And what is that on our calculator? Minus 1.24, okay? Non-spontaneous. This is a dead battery, okay? So that is the standard voltage. Okay, it's asking us to calculate the equilibrium constant in this problem. All right, so what is the how will we calculate the equilibrium constant? Which equation shall we use? We got we'll use this one. Okay, we got E cell, and then we got R as a constant, T is 25 degrees, and what is N? How many electrons are being transferred? 2, so this is a 2 electron transfer reaction. Okay, and F is a constant. Okay, so this is the equation that we will use. All right. Okay, so let's use this equation. Okay, we will use this equation and then we will solve for K. Right, what is E cell? Okay, it's minus 1.24 volts. R is, I'll give you R, okay, it's 8.314 joules per mole Kelvin. Now K is unitless. That was a question on the exam. K has no units. So Okay, the temperature T is 25 degrees, so we'll convert that to Kelvin, which is 298. I'm not putting in units because K doesn't have units. N, what is N? Okay, this is a 2-electron transfer reaction. Okay, the Faraday constant, which is F, is right here. Okay, I'll give that to you, 96,500. Very good. Okay, so here we're going to solve for K. Okay, this will be the answer to our problem. All right, so I'll do this on my calculator, which I don't have a calculator, and then I'll do minus 1.24 divided by that. Okay, my calculator died. All right, so 8.314 times 298. Okay, divided by 2 times 96,500. Okay, this is what I'm getting. So minus 1.24 equals, you guys got that? Okay, 0.012837. Okay, times natural log of K. All right, so then minus 1.24 divided by 0.01283 equals natural log of K. So how will we get K? Okay, we will do the inverse natural log of that. Okay, so I'm going to take this minus 1.24 divided by 0.01283. And then I'm going to do the inverse natural log. Okay, shift natural log of that answer. I'm getting 1.06 times 10 to the minus 42. All right, so this is the answer. Alright, so you notice here K is really small at 10 to the minus 42. Okay, that's a very small number. And you notice the voltage is negative. Okay, so favors the reactance because K is small. Okay, favors the reactance because this is a dead battery, negative voltage. Alright, so these are the types of problems that you'll see on next Friday's exam. So make sure you're comfortable doing that. Let's do one more here along the same vein. Let me set the time here. I calculate the delta G for the following reaction at 25 degrees C. All right, so we can avoid you can put the numbers in, but I'll show you, we're going to split this apart, add them back together, and get the original answer. Right now I'm going to split this into anode and cathode. Okay? So first we have Al plus 3 going to Al. Okay, we're going to do this in blue ink. Okay, Al solid. Okay, so I'll put in the we'll get the numbers back. You know, it's kind of like taking a puzzle, breaking it apart, and then putting the puzzle back together. So when we break it apart and put it back together, we'll regenerate this. All right, how many electrons and where should it go to balance this? Okay, 3 on the reactant side. Okay, so this is reduction. And what is the voltage associated with this? You guys see this here? Negative. Okay, negative 1.66 volts. This is the E cathode because cathode is where reduction happens. Okay, this is a reduction half reaction. Make sure you know this, okay, for testing. This is a reduction. All right, next thing here is magnesium. We'll do this in black ink. Magnesium goes to magnesium plus 2. Okay, how many electrons and where should this go? 2 on the product side. Okay, 2 on the product side. Okay, this is the anode. Let's look at our sheet here. Okay, this is what we get. All right, what should we do with this number? Negative 2.37? Yeah, very good. Flip it. Okay, so we're going to flip this as positive 2.37 volts. This is the anode. This looks to be and this is oxidation. Yeah. Oh, I don't know. All right. Okay, so we'll multiply the top half reaction by 2 to cancel out the bottom half reaction, which we will multiply by 3. This is a 6 electron transfer reaction. Okay, this is a 6 electron transfer reaction. Okay, so that makes it 6 electrons plus 2 Al plus 3 goes to 2 Al solid. And then this still stays at minus 1.66 volts. And then I'm multiplying the bottom one by 3. This still stays at 2.37 volts. This is the anode. Okay, so this is a 6 electron transfer reaction, right? 6 electron transfer reaction. Right, the 6 electrons cancel. This is E cell now. 1.66 minus 2.37, or 2.37 minus 1.66. What is that on our calculator? 0.61, 0.69, 59. Okay, so this is positive 0.71 volts. Okay, right, positive 0.71 volts. You got it. And this is my net one, 3 mg solid. My net one is the same as this. Like I broke this apart, I put it back together, but now I got my E cell. So 3 mg solid plus 2 Al plus 3. Goes to 3 mg plus 2 aqueous plus 2 Al solid. This is positive 0.71 volts. Okay, so I got my E cell here. Okay, as Susanna told us, we flipped the bottom and we kept the top the same. This is exactly the same as this equation, but we got our 0.71 volts. Okay, how will we calculate delta G? Which equation shall we use from our list? I see here this equation, delta G naught is equal to minus NF E cell. Okay. Okay. So this is minus 6, right? N is 6. This is a 6 electron transfer reaction. F is 96,500 joules per mole Kelvin. That's also, no, joules per mole. Yeah, joules per mole. Actually, it's not joules per mole, it's volts per mole. Okay, volts per mole. Okay. No, it's not. What's the units of joules over a volt? Okay, 1 coulomb is joules over a volt. I'm just getting the units all. Okay, 1 coulomb is joules over volt. Okay. J is joules, V is per volt. Okay. So joules over volt, joules over volt. Okay, what is E cell? We just calculated that as positive 0.71 volts. Okay, make sure you put the right units in on your exam. I think a lot of students are not putting in the units. The right way to do this is to put the units on. All right, so 96,000 joules over volts. I'll give you this constant. I'll give you the right units. E cell, which is what we just calculated, minus N. This is a 6-electron transfer reaction. So volts cancel. What's 0.71 times 96,500 times minus 6? Okay, got it here. Getting about minus 411,000. Okay, I'll divide it by 1,000 to get minus 411 kilojoules per mole. Okay, or just minus 411 kilojoules. That's fine. I want to bring your attention to something. So first of all, you can do minus 411, or you can do 411,000. That's fine, which one on the exam. Okay. Okay, but this is positive voltage, and then this is a negative delta G. What do those two symbolize? Okay, they symbolize a reaction that favors the products. Okay, and then negative delta G, it's an exergonic reaction. Right, can we do this on the exam? Okay, provided I give you these equations. Okay, make sure you pick the right equation. Can we do this? All right, our last bit here is the Nernst equation. Okay, this is the last couple of pages of our notes. The Nernst equation determines E cell under non-standard state conditions. I'll give you this equation also on the exam, but what you want to recognize is non-standard state. Okay, so we have E cell, okay, which is not E cell. It's not the same. Okay, this is under non-standard state, maybe 35 degrees, maybe 75 degrees, maybe 2 molar, whatever it is. Okay, it's non-standard state. We also have standard state delta G and non-standard state, whatever that is. Maybe it's 100 degrees, maybe it's like 5 molar. Okay, so these equations for non-standard state conditions, we will use the Nernst equation, particularly with E. Okay, notice that to get E for non-standard state, you need E at standard state. Okay, just like the same reaction we saw for delta G. Remember this equation? To get delta G at non-standard state, you need delta G at standard state. All right, I'll give you this equation, but I'm just telling you to get non-standard state, you need the standard state values. All right, Q. Okay, so there's 2 versions of the equations. I'll give you one or the other. You just plug and play. Okay, here we have Q, and we use Q to compare to K. So using the Gator rule, if Q is greater than K, the reaction favors the reactant side. We predict a negative voltage, okay, which is like a dead battery. Okay. If Q is greater than K, favors the products, okay, and that's a positive voltage. Okay, this is a battery, okay, with a positive voltage. Okay, Q less than K, look where the alligator jaws are pointing. Okay, this favors the products. Okay, if Q is favoring the reactant side, it's a negative voltage, okay, because it's not favoring the products. Okay, and finally, if Q is equal to K, you have 0 voltage, you don't have a battery, okay, no battery. Okay, you don't have a battery. Right, so that is where we compare Q to K. Okay, we can use the Gator rule, and always in the Gator rule, where does Q go? On the left. Okay, put Q first, in other words. Okay. All right, Nernst equation, non-standard state. I'll give you these equations. There's a natural log form. There's a log form. I'll probably give you this version on the test. Okay, so don't need to memorize it. Okay, don't memorize it. I'll give it to you. You just need to know how to plug and play with it. Okay, and what are we looking at here? Non-standard state. Non-standard state. The previous equations are all standard state. Okay. All right, well, the following reaction occurs spontaneously. Okay, we're looking for positive voltage. Okay, at 25 degrees, given that iron is 0.60 and cadmium is 0.010. Okay, so let's see how we can use the Nernst equation to solve this problem. Let's see if we can do this here. So in purple, I'll have cadmium going to cadmium plus 2. How many electrons and where should I put it to balance this? On which side, Susanna? Okay, so this will balance out the charge. And what is the voltage associated with that? Okay, do we need to flip it when we read it off our sheet? Yes or no? Okay, here we have cadmium plus 2 electrons goes to cadmium solid. Okay, this is reduction. What do we see here in this particular problem? Okay, we see it losing 2 electrons, so it's oxidation. We will flip it. Okay, does everyone see why I flipped the sign? Okay, why did I flip the sign? Yes, it's losing 2 electrons. I flip the sign from here. Right, Fe plus 2 goes to Fe solid. Right, how many electrons and where? Okay, so this is the cathode. It's gaining 2 electrons. And what's the voltage for this? Anybody see it here? Here we go. Do you guys see it? Is it? I think it's negative 0.44.
CD, right?
CD is 0.40, but we flipped it. But the next one in black is iron plus 2 going to iron solids. So what's the voltage for that? Do we flip it? No. Okay, 0.44, we don't flip it because this is gaining 2 electrons according to this equation. Okay, everyone see that? Okay, so how many electrons are being transferred in this reaction? Okay, this is a 2 electron transfer reaction. Okay, this is a 2 electron transfer reaction, so we'll calculate E cell as negative 0.04 volt. Negative 0.04 volts, so that looks like it's non-spontaneous. This looks like a dead battery. Okay, and then our net is Fe plus 2 plus CD solid goes to CD plus 2 plus Fe solid. Okay. All right, so that's at standard state. Are we at standard state? Okay. Okay. Okay, standard state, this would be 1 molar. See? Standard state, we would be at 1 molar, but we're not at 1 molar. Okay? So we're going to use this equation here. All right. Okay, let's figure out Q first. Okay, make sure I have enough time here. Let's figure out Q first. I don't have any time. Okay, so we'll calculate Q. What is Q here? Okay, products over reactants. Okay. Cadmium concentration is 0.10. Iron plus 2 concentration is 0.60. Okay, what is E cell here? We just calculated E cell. And what is N? N is 2. Okay, so we will plug that in here. All right, so I'll give you a video to watch on Friday. If you turn that in and do your notes, turn that in, I'll give you extra credit towards your homework. Okay, so we calculate Q. Okay, N is 2. E, we just calculated E cell here is minus 0.04 volts. All right, so Monday we will do a review. Wednesday we will do some more review, and then Friday we'll take our exam. This is our last exam. Okay, I do want everyone to take a final though, even if you have an A in the class. Okay, that's for my evaluation. All right, have a good Easter break. Please watch the video. We're almost done. Almost done. I promise. We're at the finish line.